Welcome and thank you for joining the demo of my final project, procedural quest generation in role-playing games using large language models. This project showcases how cutting-edge AI can transform RPG quest design, creating dynamic and immersive experiences with minimal human input. We'll start by exploring the quest editor window. This interface allows us to define key parameters for quest generation, including the quest prompt, objectives, and other essential details. Here we're refining the sample locations to include only the ones we need, followed by editing the characters. By streamlining these prompt parameters, we make them more concise, which enhances the overall quality of the generated quests and other essential details. For this quest generation, we'll be using Llama 3.1 as our large language model. The pipeline is also compatible with other models, including Gemma 2 and Mistral Nemo. After a brief wait, the system generates the quest for us. Next, we review the generated quest to ensure that the quest name, description, and goal align with our expectations. We then focus on the list of generated objectives, editing them as needed to fit our requirements. In this instance, I'm removing any objectives that are not necessary. Next, we apply the same process to the rewards, removing any unnecessary ones. It's important to note that rewards are automatically assigned when the quest asset is created. The system utilizes Unity's resources pipeline to fetch the required references. If a reward doesn't exist as an asset within the resources folder, the system will return an error. And there you have it, it's that simple. Next, we'll demonstrate the dialogue generation pipeline. All we need to do is assign the reference for the quest we want dialogues for and hit generate. We're not completely satisfied with the generated dialogue this time, so we'll clear it and run the generation again. Similar to the process for quest generation, we carefully review the generated dialogue tree to ensure its quality and coherence. We examine all conditions and results to confirm that they make sense within the context of the quest and adjust them as necessary. This review process is crucial to ensure that the dialogue aligns with the intended narrative and gameplay. For more in-depth information regarding the right conditions and results, please refer to the documentation guide included with the package. Once we're satisfied with the dialogue tree, we simply click the Create Asset button, and voila, our asset is ready. Now we will showcase the NPC editor. It is much more straightforward than the previous editors. If we assign the relevant asset and dialogue, then it doesn't even need to call the large language model. It can automatically generate the relevant prefab. If instead we want the tool to generate for us relevant enemies for our quest, then we simply press Generate Enemies and wait. Here the system has generated for us an enemy named Shadow Stalker. This sounds like the name of a wolf, which is coherent with our quest prompt and setting. We can then simply create the enemy prefab with just another button. Finally, we have the item editor, which is even more straightforward than the dialogue editor. To use it, simply assign the relevant quest asset and press Generate. Once the item is generated, we can make any necessary edits and then generate the final asset. Let's walk through an example of setting up a complete quest. First, we generate the NPC Eldara, who will serve as our quest giver. As you can see, the prefab has been configured with all the necessary assignments and references. However, some fine-tuning is still required. First, we need to assign an appropriate model to our NPC. Once that's done, we should configure the hand transforms in the fighter script to ensure everything is set up correctly. Before we can complete Eldara's prefab, we need to generate the item required for the quest. We start by opening the item editor to create the item. Once the item is generated, we also need to assign an appropriate model to it. Let's examine the quest asset. For Objective 4, we need to give the Starlight Bloom Herb item to Eldara. To do this, we scroll down to the Inventory Changer component and assign the item reference. Since this item should be removed from the inventory upon completion, we also need to check the Remove box. Next, we need to bring our assets into the level. Start by adding Eldara to the scene. Then, switch to the other scene. Here, we'll examine the Quest Proximity Checker asset, which is crucial for Objective 2, as we'll see shortly. We'll also add the necessary pickup spawner to the scene. With everything in place, we're ready to start playing. We begin by approaching Eldara, who will provide us with the quest. Once we interact with her, She will give us the details and objectives for the quest, setting the stage for our adventure. Next, we make our way to the Whispering Woods and open our quest logs to review our current objectives. As we approach the Starlight Bloom pickup, the proximity checker updates our quest status, marking Objective 2 as complete. We then collect the Starlight Bloom, which fulfills Objective 3. This progression confirms that our actions are aligned with the quest requirements and that we're advancing toward completing the overall quest. Finally, we head back to Eldara and speak with her again to deliver the Starlight Bloom, thereby completing Objective 4. This marks the conclusion of our quest. After finishing the conversation, we open our inventory to find that we've been rewarded with a healing potion. And there you have it, the Campbell-Quest pipeline and Unity tool in action. This demo has showcased how the system facilitates quest creation, dialogue generation, NPC management, and item integration. I hope you found this demonstration both informative and engaging. If you have any questions or would like to explore more about the project, feel free to reach out. Thank you for watching.